Look at any standard AI workflow today, and you'll see a massive, invisible torrent of data moving across the network. Even a simple prompt requires shipping text to a distant server, processing it through massive GPU clusters, and waiting for the response to travel back. In this model, the modern PC functions as a thin client. It relays prompts to cloud APIs while computation happens thousands of miles away. This total dependency creates a strict trilemma for enterprise AI. Companies face steep inference costs, unavoidable latency, and severe privacy risks every time proprietary data leaves the device. Scale that friction across thousands of employees, and the bottlenecks become crippling. NVIDIA is addressing this bottleneck by pivoting to own the endpoint platform, controlling the full AI computer rather than just its internal accelerators. Their hardware solution is the RTX Spark superchip, a custom-built processor designed specifically for Windows AI PCs. This chip delivers 1 petaflop of performance. That specific threshold provides the necessary compute to handle continuous agentic workflows and run large language models locally. RTX Spark represents a structural redesign intended to establish the personal computer as a local, functional node within the broader AI infrastructure layer. Running advanced AI locally requires overcoming a physical data bottleneck. Traditional hardware architectures cannot move data fast enough to keep the processors fed. A local 120 billion parameter LLM demands an enormous amount of memory. The system must simultaneously hold the model weights, the KV cache, extensive context windows, embeddings, and agent states. Standard x86 architectures segregate the CPU and GPU into distinct memory pools. Every piece of data must pass through the PCIe bus, creating a severe choke point. When you attempt to load a massive LLM, transfer speeds stall, and system buses saturate instantly. The RTX Spark architecture solves this by integrating a 20-core ARM-based Grace CPU with a 6144-core Blackwell RTX GPU onto a single package. To bypass bus restrictions, NVIDIA connects these processors using an NVLink C2C interconnect bridge. This allows 128 gigabytes of unified memory to form a massive resource pool. Massive LLM data blocks sit entirely in shared RAM, eliminating slow transfers across separate buses. Because of this, RTX Spark systems can run 120 billion parameter models directly on the device, supporting context windows of up to 1 million tokens without stalling. Removing this physical memory bottleneck is the mandatory physical prerequisite. Once the hardware can hold and process the data locally, the laptop transitions into a true edge execution node. With the hardware in place, the software stack can shift toward agentic computing. Instead of a human manually clicking through separate applications, an autonomous agent executes tasks, reasoning across multiple apps simultaneously. This capability introduces a severe security dilemma. Granting an AI agent access to sensitive financial data is unacceptable if that information must be sent to an external cloud server for processing. Microsoft and NVIDIA collaborated to build a secure, local platform for on-device agents directly into the Windows operating system. The first layer consists of new Windows security primitives. These provide OS-enforced identity and strict containment, ensuring the agent only accesses authorized files. The second layer, NVIDIA OpenShell, acts as an intelligent traffic director. When a query hits the barrier, OpenShell instantly verifies it against privacy policies. It routes sensitive workflows directly to the local GPU for processing, while sending anonymized queries to a cloud API. Leading open-source agent networks like OpenClaw and Hermes Agent are adopting this architecture to guarantee privacy on local devices. Without this strict OS-level routing stack, enterprise adoption of local agentic AI would be completely blocked by regulatory and compliance friction. For the AI engineer, this local infrastructure alters the mechanics of their daily workflow. Right now, development iteration speed is capped by cloud access. Every experimental run, every slight tweak to a model requires packaging data, pinging a distant server, and waiting in a queue for the result. RTX Spark enables a clean development lifecycle that drastically accelerates iteration. Tasks like prompt testing, pipeline evaluation, and synthetic data generation happen instantly, directly on the device. The workflow only moves to the cloud data center once a model is explicitly flagged as mature. This local loop eliminates the marginal API cost for every experimental test run and sharply cuts data transfer overhead. Major hardware manufacturers are adopting this exact platform to supply corporate IT departments. Equipping developers with an RTX Spark machine is a direct infrastructure play. It reduces a company's dependency on expensive cloud GPU rentals by moving the bulk of the experimentation process in-house. This localized computing power does not mean the cloud data center is obsolete. The architectural reality of enterprise AI infrastructure will be strictly hybrid. This topology creates a clear division of labor. On the endpoint side, you have the local edge node. This node handles private context, low latency fast inference, offline workflows, and persistent personal agents. On the other side of the division is the cloud infrastructure. The data center retains responsibility for distributed training, massive batch jobs, and running frontier-scale models. RTX Spark makes this architecture viable by giving the endpoint device the compute and memory required to pull its own weight in the workflow. NVIDIA is leveraging this shift to expand beyond graphics cards. They are positioning their architecture to be the default silicon and software layer for the agentic PC market. This creates a cohesive global computing network, distributing the massive computational load of AI across millions of endpoints. With RTX Spark, the laptop serves as a foundational, executing node of global AI infrastructure.